I'd like to call upon our last speakers of the day to come on. We've got two speakers, Lingyit, who's an actuarial, who's an actuary by training, has lots of experience in the insurance industry, most of which is with primary insurers, but also in various analytics roles. So we're joined by Lingyit and Bala, who is an associate data scientist in a consulting unit at Munich Re, and they will be discussing data analytics. They'll be discussing a new era of actuarial analytics in non-life insurance. So I'm very interested to find out about that. So over to you guys.
Thank you. Hi, everyone. I'm Bala. I'm an associate data scientist in Munich Re, and I have my colleague, Mr. Lingi, who is a machine learning engineer in the global consulting unit, as same as our previous presenter. And then today we'll be walking you through our recent use case, which is just quickly let me share my screen. So today we'll be walking you through our recent analytics use case around the claims analytics piece for a primary insurer, where we covered kind of the fraud detection piece. With this introduction, I'll be moving into the agenda. So we have divided agenda into two sections, where in the first half, I'll be talking about why do we need the fraud detection in the first place, and what are the standard industry approaches that are currently in place among the primary insurer. Then we will deep dive into the case studies. One is with the motor insurance, and my colleague Linky will walk you through the health insurance as well. And finally, we'll be talking you how do we kind of productionize our use case in Munich Re setup. And finally, we'll conclude with how do we collaborate with the primary insurer in the Munich Re setup. With this introduction, I'll just jump into the first piece, like why do we need a claims fraud detection? So if you look at the fraud, right, fraud is almost a major topic across the globe, and it's omnipresent everywhere, right? If I start from the West, the United States, where in the last year there was close to almost $40 million worth of insurance fraud took place, which is the study tells us. And if I move on to the middle part, where in the United Kingdom, so there is a particular gang that was caught, where this gang kind of network was colluding among themselves and trying to create this kind of crash for cash benefits, where they were able to find out close to 170,000 of close to insurance claims that are linked together. And if I move to next, if I move on to the Indian one, right, where almost close to 60 million insurance of fraud that took place, and all the study tells like close to 10 to 15% of the market business getting affected across the business in the insurance companies. So fraud is kind of a pretty predominant topic across the globe. Next, if you look at the definition of frauds, right, it varies with respect to the markets, and it varies with respect to the, I would say, business, what you're dealing with, and the regulatory government that's getting involved here. So for example, here, what I'm showing you is kind of from the health piece, where we can classify into three stages, like waste and abuse and the final hard fraud. So in the waste, we have listed down what could be the behavior, right? If it's kind of a mistake where we kind of inefficiency of the service, then it's kind of not as severe as how we can be intentional patterns that kind of build and but not performing the service. So I would say the fraud kind of varies with respect to each and business, and the degree also varies. Next, if I move on to the industry approach, what are the current procedures that have been placed in the industry, right, in the primary insurance setup? So we are classified with respect to two axes. One is time taken to implement in the market or time to the market, and other one's the data and the infrastructure requirements that are needed to have in place and the effectiveness along the scale, right? So if I start with the basic one, which is a kind of a reputation list, where insurance company has the blacklisted agents or the doctors or the hospitals or the workshop, right, in case of motor insurance. And then they can simply monitor whether the claim is coming from this particular garages or the hospitals. Then we kind of pull out and send it for the investigation team, which is the simplest one. And in the next setup, right, we kind of frame the rules where we have a, I would say, interaction of various variables and the various parameters coming into the picture. And we can assign, I would say, weights for each rule. and check the scores and the weights. So this would be like one level or one step above the reputation list. Next, we can make use of the machine learning models. Like we can train based on the historical data, whether the primary insurer has done investigation in the past, or we can try to study suspicious patterns from the unlabeled data set, try to pull out the, I would say, suspicious claims from the common patterns. Next, finally, we can do some network analysis based on the interaction of the networks or the parties that are involved in the claim, where we try to study the relationship between the entities that are present in a particular claim, like it could be hospitals, agents, or the investigators, etc. Right? So we try to learn the pattern from them and pull out the suspicious claims from the patterns. So this would be the, I would say, current approaches that are currently in the market. When we work with the multiple insurance companies, right? When we did the workshop and tried to understand the pain points, we kind of generalized into 4 key main sections. When we look at the claims processing, most of the investigation pipeline is a manual one, where they kind of manually select the claim and send it for the investigation. And there are some automation involved, but not a complete one. And there is no feedback loop associated between the whatever the investigation result and the claims processing input stage, right? And there is no loop. So there is no learning from the past experience. Because of this manual process, we do see like a low investigation rate and low fraud hit rate. For example, one of our clients had like close to 1 to 2% the investigation rate, and the fraud to hit percent is close to 3 to 5%. Next, if I move on to the next one. So currently in place, most of the primary insurance has some general rules, but the rules are very generic, which don't reflect the fraud nature or are not updated to the market. And they have some machine learning model, which is kind of black box for them. So they were not able to interrupt why the particular model is giving me this result, or the particular claim has been tagged for suspicious claims. And the final problem we have typically encounter is with respect to the data quality. So where we have the evergreen issue with the data completeness and the inconsistent format, and you can see spelling mistake across the variables like the lost locations, like a vehicle make and manufacture. So this could be one of the key pain points. So we try to generally address all these pain points in our use case. Next, I can move on to the particular case study with respect to the motor insurance, what we did for the particular primary insurer. Then let me jump out to the objective of the fraud detection approach, right? You can assume fraud detection kind of a funnel where we push all the claims into it, and then we're pulling out the suspicious claims or claims just more patterns or kind of thing. Only those claims has to be sent for investigation. And then after the investigation, where you do a hardcore investigation, look for hard supporting documents to prove the claim is a fraud. So it kind of having a two-stage approach, and we have like 2 filters where we can have two-stage approach. And the 2 main KPIs that immediately will come into the discussion was just the investigation rate. So one of the primary reason will be like to improve the investigation rate, but at the simultaneously, you can just, if they have the capacity to investigate all the claims, they are happy to do it, but we have to pull out only the suspicious claims that has been sent for investigation. And the final one is the fraud rate. Out of the claims that has been sent for investigation, how much claims are actually being fraud? So these are the 2 main percentage KPIs we'll be looking at. And if we look at our recent use case, right, what the situation was there in the primary insurance was they had only like 10 to 15 manual rules applied in their system, and it's a semi-automated. It's not a completely automated one. Still, there is a human in the loop. And the approach we brought in was like we combined the rules and then we added more expert rules from our side. So we have worked across the various market, right? So we have brought in all the rules from the other market as well and implied on their data. Then we use machine learning models, both supervised and unsupervised approaches, to come up with a more predictive modeling approach. Then finally, this in turn improved their investigation rate. We almost like improved 5 times what was their current investigation rate, and the end fraud rate also we almost like improved 3 times. And then when we calculate the estimated claim amount that could be replicated because of our action rate, we had close to 150,000 euros. So this was the final impact that was created by our engine or the analytical use case here. With this, I'll deep dive into some of the sections what we did in the use case. So the standard with respect to the claim, right? We try to analyze claim from the various aspects. So we try to feature engineer as much as feature that's possible. For example, you can have derived feature like a close proximity to the policy start date and an end date. And you can have like one customer view. And then we can see like from this customer, how many claims came in the last 12 months and the last 1 year, and what is the frequency between these claims. He has submitted any fraudulent claims earlier, or he has submitted total loss claims earlier, and what are the product type he has subscribed to, like the premiums and the what vehicle he has, whether he has a premium one or the medium category vehicle, etc. Based on these features, right, then we kind of decide whether the claim has to be sent for investigation or not. So this is one of the primary important stage, right, in every machine learning project, where you need to try derive as much as feature that is possible. Next, we had a two-stage approach for our rules engine, or for our fraud detection piece. Well, first stage is the rules part, where along with the, I would say, the 10 to 15 generic rules that was provided by our client, we added more like close to 40 to 50 new rules. The rules is not just a single variable, I would say, it is a combination of multiple variables. For example, you can look at the rule 2 here, where we have the loss hour, which is happening in the late night, and we look whether it's a weekends on the public holiday. And similarly, the vehicle, whether it's a premium one or the average vehicle brand, along with the vehicle age, etc. So we try to create which is kind of a more suspicious pattern or the most suspicious variable. We have interaction with the claims team on the ground or the investigation team on the ground to pull up the most important factor. Then we kind of brainstorm with them to come up with these rules. And all these rules, right, will be evaluated and then scored on their data. So we kind of assign the weightage. Like for example, a rule should, on a scale of 0 to 100, rules can have like 180 depending upon the importance that is in the data. To derive this rules score, right, we use some of the factors like how many fraud claims it is capturing, what is the savings it is bringing from the previous historical data, how many claims that is getting triggered because of this rule. So we consider this and we apply kind of a weighted algorithm to come up with the final risk score, so that each rule don't have the same weightage based on the data and the portfolio. Each rule have a different risk scores. So once this step is done, then we are move on to the predictive machine learning part. So we typically have the policy and the claim and the investigation data. And from Unicre side, we'll try to add some more external data like the public holiday information and the vehicle up to the market information and the criminal financial scope, zip codes information. So we try to enrich as much as data possible from our end. And once we have the data, then we try to look up, okay, what kind of modeling can be done. Typically, we start with both a supervised approach and an unsupervised approach. In supervised approach, we try to learn from their historical flag or the historical data, whether what investigation and their output. And in unsupervised approach, we try to pull out the suspicious pattern, which is kind of the outliers, and then we kind of add into our data for the machine learning models. So in this way, we kind of study on the impact of the predictive machine learning model, how it impacts the current process here. And then if you look at the final output here, so the standard, we'll be giving out like a claim scorecard. For example, when we can take a claim 2, right? It has satisfied like 2 rules, the rule number 44 and the rule number 49. And the total risk score for the rule is like kind of 110. And the machine learning model says 0.95. That's more close to it's being a fraudulent claim. So based on these two metrics, we discuss with the client team and decide on the threshold, how do we trigger the claim and how much percentage of the claims has to be triggered. So then we come up with the final function based on these two, I would say, risk score on the model probability to pull out the claims for investigation. And we just don't stop at we'll just go one step down and try to understand what are the important factors that is deciding these probabilities and deriving my decision, right? So we use some of the standard packages to come up with the model insights. Like for example, here you can see time taken to report the claim is the most important factor for me. And I look at what is the relationship it has with respect to the target. Here it's a fraud. And I try to study whether it's a linearly monotonic one or the complex functions. As you can see here, it is a linear function. As the time taken to report, the probability also getting increased. So in this way, we can be able to study the variable and its impact on how the decision has been made in the final stage. And this would be like our typical output that we'll be sharing with our clients. And with this, I'd like to hand over the session to my colleague, Mr. Lingi. He will be walking you through the health insurance and on how do we productionize our use case in Unicre.
Thank you, Bala.
Thank you.
Thank you. And thank you, Mehul, for the introduction. Maybe let me share the screen. All right. All right. So, yep, thank you for Bala for walking us through on the motor insurance sites. For my part, it's more for the health fraud study that we have done with a client that is ongoing. The problem statement that we were trying to solve is quite similar with as Bala has showcased. We were trying to understand the pain point from customer, and then we have 3 approaches listed here that try to tackle the pain point. So the one that in the middle, you could see that there's a 3-party relationship between the provider, doctor, and patient. And the provider being the healthcare provider, in this case, the hospital, and then the patient and the doctor. Hospital, we were looking at if, let's say, there's any length of stay or checkup bill prices, or the procedure was being done not justifiable, or there is a high frequency of readmission. These are the kind of scenario that we try to avoid, and then try to be the part of the scope of this fraud study, and what we try to tackle using these 3 approaches. So what you can see here, there is a fraud, and then there's the abuse and the overcharging. Fraud would be like some unperformed services, hard fraud. And then abuses could be the unjustified services, like, for example, certain procedures shouldn't be done in this way. So we will use outlier detection and static business rule to identify all these cases. And another dimension to look at is, for example, the patient. Looking at the comorbidity study, for example, how correlated one diagnosis is related to another, or whether or not same family member coming from the same household was also claiming during the same time. It's quite silly, but definitely we have seen such cases. And for example, like patient having non-disclosure when they have pre-existing condition, but on the sign up, they never self-declare. So those things that we were trying to use these 3 approaches to identify in the early stage. And here as well, the doctor, when we look at the doctor specialty, compare it with the medical condition, whether or not the doctor, for example, like pediatrician doctor, but is doing a heart surgery operation, something will be raising a red flag. And whether the doctor is a certified doctor, we will check to the public repository to verify all these things. So quite similar to what Bala has mentioned just now, but in a different context. So for example, we have the static business rule. If let's say a pregnancy ICD code, which is the medical condition that submitted in the claims, but was diagnosed in the males. The patient is the males, the claimant is the males, something is weird, we will flag it out. Or if it's a pediatrician ICD code that diagnosed in the adults, or sometimes just the procedure, but this is coming more from like personal experience. Sometimes from the blood test, when you see the slightly elevated liver enzyme level, the doctor will just ask you to go to the ultrasound rather than doing the CT or MRI scans, because that's just too expensive and is overdoing it. So all these business static rules is what we use. And then after adjusting, like similar to the motor side, we look at how much fraud rate we can get from a particular rule and how much saving we can get from a particular rule. And we will have the taken into account of all of them into a consideration and to derive the weightage with the domain experts. The next one would be more for the predictive analytics side. So we not only, because now we are handling the healthcare data set, so we have the diagnosis description, we can do text-based processing and text-based predictive modeling. So looking at this, if you see the word cloud here, the blue color text here would signify that a positive correlation with the admission to the hospital. Whereas on the other side, the orange here, all this malignant, pulmonary neoplasm has a negative correlation to the admission. We are using these insights to determine the likelihood of readmission versus the actual outcome. If a patient was found that there's a low probability to be readmitted to the hospital, but indeed this patient was admitted to the hospital, then we will raise a red flag. So these are the kind of scenario that also we are not just looking at the diagnosis description. Sometimes we are doing the correlation between the diagnosis code and look at the comorbidity study to determine if there's any anomaly. Certain medical condition happen together with another, but there are sometimes the condition itself just very rare cases that will raise the red flag. Here we want to talk about the ML ops as well, because doing the modeling, sometimes it's not just having the academic exercise of running the machine learning workflow. We also want to look at not just using the machine learning algorithm, but when we are doing the development, but we also want to operationalize it. That aims to achieve the improved quality and the reliability of the production model as well. So that at the end, we can reduce the time to market and then we can scale. And because we have incorporated the compliance and regulatory framework inside the whole process, then the entire thing can be automated and then the time to market can be reduced. Which is why here, what do we mean by ML ops? If you can see here, the dark blue color here is more for the standard machine learning workflow. We have the data ingestion, the exploratory analysis, and the feature engineering, data processing, and the model training and evaluation. But here, the whole other spectrum of the workflow is that we need to have the infrastructure, we need to have the auto scaling to handle the large volume of data. We need to have modular way of productionizing the model and performance tracking and online monitoring or online training. Which is why here, we want to also show you that the machine learning in production is more than just model development. As we can see, sometimes we write code because we want to let the automation take over, and then there will be free time in the future. But if it's not being built and it's not being deployed properly, we end up doing more and more coding, we end up doing more and more debugging, and then there's no time for the original task. So if you look at the right-hand side here, the adoption of AI, and in terms of the AI deployment, we want to show you here that you can see the blue color here, 47% are just doing AI pilots, and only 53% in 2020 are doing the first production case. If we break down by the sector, looking at insurance is even quite scary, because only 6% of the cases insurance, we have only achieved the wide-scale AI deployment. So it seems like the machine learning operation is not ready in the insurance industry. Here, the data science factory is for our in-house software framework. We're trying to achieve these few targets, the reproducibility, and be able to evaluate the model in real time, automate the whole thing, monitoring, doing the testing, and have the modular architecture. Here, this is the technology we developed to enable the success. In this case, I wanted to show you, because this is actually quite a bit too involved. I wanted to demo to you that what we just mentioned, you wait a second. Oh, sorry. What we just mentioned can be seen here. Wait a second. Yep. So what we were saying, what I was sharing with you just now, if we have a model running, but how easy is it for us to maintain the model in production, and how easy it is for us to refresh the model, or to maintain the model, or to upgrade the model. If you look at this, we have an API here, the interface that I'm showing. What I'm doing now is that this is the model that we are running in production, and this is the API. So if we send a data to the API, we can receive a real-time scoring, doing on a transaction level. But now, if we are doing it with another, for example, here, I have a different data set. This data set contains more data because we managed to collect more data. But now this model doesn't take into consideration of this new data, because this model is an older version. And if we want to upgrade to a higher version, how easy for us to do it? For example, here, if we want to do promoting the model into using the latest version, could be just one click away. And then the moment when we do it, in a split second, now what client will be able to send to this URL will be a refresh scores. And what from the IT side, what happened is that they can send something like this. Sorry about that. All IT need to do, or what we can provide as a value service, is that there's the API endpoint that point to the production model. And when we are changing the model, or from the client side, they were being highly aware of all the complexity. And when they send a new set of data, they will get a different refresh score. So all of that can be done in a split second. And then all of that will allow us very timely deployment to the market. Sorry for the hiccup. Maybe let me share again here. Lastly, the collaboration. We want to, not only because Munich Re, we have the market presences across the region, we also have the best practices like what you see from the technology and from the analytics perspective. And we can also offer the tailor-made fraud detection engine for the individual customer. But what we have here is that we need to have the local engagement with the local companies, that we will conduct data workshop and working with the claims and investigation team to share their experience on the ground and having the constant engagement with them to receive the feedback from time to time, so that we are offering a fit for purpose for detection and which can be continually refined. Lastly, we know, just a quick wrap up, we know there's a stronger need to digitalize, automate, and using advanced analytics within the insurance industry, especially for non-life business. So for the fraud detection that we have demonstrated, there was a five-fold increase in the rate of selecting suspicious case for the investigation as presented by Bala, and then the threefold increase in the rate of identifying the correct fraudulent case. So in order to enjoy the benefit of the advanced analytics, the end-to-end solution that I demonstrate just now, it's just an API endpoint. And then from the customer perspective, all they need to do is we can then very easily operationalize the API endpoint for them, and then they can enjoy the benefit of the advanced analytics. And given our cross-region market presences, the best practices that we apply just now, if you demo to you, analytic solutions such as the fraud detection can be tailor-made and continually refined. Thank you for the attention. I think I'm complete.
Okay, great. Thank you, Lingyit and Bala. Very, very interesting, and probably quite a topical topic of fraud detection, something that's quite prevalent concern for insurers in the region. I'll wait for questions to come through. Okay, we've got the first one. In your model validation process, do you also measure the false positive rate? Can imagine there is a cost for investigating legitimate claims. So is that something that's part of the process?
Yeah, I can take a question. Yeah, definitely we will be looking at the false positive rate, and we have the cost per average, or the average cost per investigation claim. Then we consider those to a cost benefit analysis. Then because we try to get input from the client, right? Like how much percentage of the claim they have to investigate. So based on that, we do the cost benefit analysis by taking their average cost of the investigation. Then we give them the, I would say the business KPI.
Okay, thank you. We'll wait for some more questions. More for me. How much actual fraud data do you need or use to calibrate your models and rules? How much do you typically kind of start to capture?
So I would say in the past experience, based on the past experience, like we had close to maybe 0.1% of the total claim volume, I would say, that was referred for us for the internal fraud, right? Because definitely you can't expect like if it is more than 1%, then there is something wrong or something happening. So we kind of do some sampling techniques before the modeling stage. So we have some basic proportion to have enough predictive power. So I would say that could be the number, if you're looking for the numbers.
Okay. And did you augment that with any external data sets, or do you typically base that on the insurer's own information?
I would say it depends on the market to market. For example, if I look at the Indian market, right, we have the Indian Regulatory Board where we can have the primary insurer can request data from what happened in the past insurance company with the client. Then they have this I think it's called IAB, Indian Regulatory Board data. So we kind of go through the request to the primary insurer to collect such kind of external data set. But other than that, we've come up from our own side, like the public holiday information, which is available from internet, we're able to collect. And in Munich Re, we have the criminal financial zip code. For example, if you're particular in the PIN code, we try to have your like the literacy rate and then other suspicious other parameters as well. How the average household income or something like that. So we make use of those to have a geolocation based variables.
Thanks for that. And then kind of a last one from me. Lingit, you mentioned wide-scale AI deployments, and they're only sitting at 6% for insurance companies. What would be some examples of wide-scale AI deployments?
Yeah, that's a good question. I would say usually because the AI pilot and the first production case was referenced in that slide. So usually AI pilot would be just really having a machine learning model running, sometimes being maintained in an ad hoc manner. And for the on the other side, in comparison, wide scale of AI deployment would be the end-to-end flow, right? Like what I tried to showcase just now, but there was changing the computer and all that. But so having that, the whole thing gets automated, very efficient. There's anytime the model degradation, it gets constantly updated. There's always the model champion and challenger, having like 20 models running in the background, always keeping track, always measuring the performance. And whoever that wins would be the champion, would be the model that we picked up, and then be the production one. That I would say the wide scale AI deployment, like some of the technology company, when you are using their product, the product is always constantly updated, right? They were training your data, they were training on your data and all that. So that I would say the wide scale. And I presumably some of the insurer which has a large ecosystem, like maybe Ping An in China, I think those are the players that would be able to falls under the category of that 6%. Yep.
Okay.